Hello guys, and welcome back to my YouTube channel. In this video we're going to be covering R versus S configuration. So first we gotta determine what a stereocenter is. So a stereocenter is going to be some carbon group that has 4 different groups attached to it. So here we have an OH group attached to the pink carbon. We also have a hydrogen. We have an ethyl group, and we have a methyl group. All of these groups are different from one another. Hence, this carbon is a stereocenter. It is a carbon with 4 different groups attached to it. Let's compare this to a structure that does not have a stereocenter. And these stereocenters are what we are going to be determining if they have R or S configurations. If we compare this to a structure that looks very similar to the first one, where we have an OH group, and we got that H group as well. Oh, is this a stereocenter? No, because we have 2 ethyl groups. An ethyl group on the left-hand side and an ethyl group on the right-hand side. Those 2 groups that I drew in pink are the exact same as one another. Hence, this carbon would not be a stereocenter. Therefore, it's not going to be R or S. Only a structure like this will be able to have an R versus S configuration because there is a carbon with 4 different groups attached to it. So now that we've covered the first thing that you've just got to know before determining R versus S configurations, let's get right into it. All right, so how do we determine if a stereocenter has an R or an S configuration? Well, step number 1 is always find that stereocenter. Step number 1 is find the stereocenter. It is usually the group with a dash and a wedge, okay? So it would be this carbon. But this is not the case 100% of the time. For example, if these 2 groups were hydrogens, then this carbon would not be a stereocenter because a hydrogen is not different than a hydrogen. Therefore, this carbon would not qualify as a carbon with 4 different groups. Therefore, it's not going to qualify as a stereocenter. But, thank goodness, in this question, that was not the case. We had a chlorine and a fluorine. So when we look at this carbon, we can say that there is 4 different groups attached to it. So now what we got to do is rank the 4 groups based on their atomic weight. And we do this atom by atom. So looking at each atom directly connected to the main carbon. We have a chlorine, we have a fluorine, we have a carbon, and we have a carbon. So who wins? Well, chlorine wins. It has the highest atomic weight based off of the periodic table. So this would be priority group number 1. So after you identify group number 1, you have to compare the other groups to each other. So who wins when you're comparing a fluorine versus a carbon versus a carbon? Well, fluorine will still have the highest atomic weight. Therefore, the fluorine will be group number 2. Now we run into a tricky situation. How do I compare a carbon with a carbon? They have the same atomic weight. What you got to do if you run into a situation where you have a tie is you have to compare the atoms that those carbons are connected to. So I'm going to label this carbon in a different color, blue. Dark blue carbon is connected to a hydrogen, a carbon, and a carbon. Light blue carbon is connected to 2 hydrogens and another carbon. So what you got to do is you got to put these groups in a line where you rank them from highest atomic weight to lowest atomic weight. So the light blue carbon, the carbon would go first, then hydrogen, then hydrogen. In comparison to the dark blue carbon on the right-hand side, we have a carbon and a hydrogen. Now what you got to do is compare these atoms row by row. 1, 2, 3. Starting with row number 1. Oh no, we have another tie. You cannot compare carbon to carbon because they are the same. So what we got to do is we got to look at row number 2, where we have a winner. We have a carbon that has a higher atomic weight than a hydrogen. So therefore, the group on the right-hand side wins and will be labeled priority group number 3. Therefore, this group is priority group number 4. That is all. So step number 2 really was ranking the groups 1 to 4. So now that we've learned how to rank the groups based on their atomic weight, the next thing we got to do is say, is this R or is it S? Now, before I show you how to determine whether a stereocenter is R or S, I want to go over the 3 typical situations that you're going to encounter. So let's say each of these carbons is a stereocenter. And group 1 is not equal to group 2, which is not equal to group 3, which is not equal to group 4. And group number 1, like we just went over, has the highest atomic weight, and then group number 4 has the lowest atomic weight. With that said, here are the 3 typical situations that you're going to encounter when trying to figure out if a stereocenter is R or S. Case number 1 is when your lowest priority group, group number 4, is on a dash. Boom. Situation number 2 is when group number 4 is on a wedge. Boom. And once again, group number 4 would be your lowest priority group based off of your ranking, based off all of their atomic weights. And then the third situation is when group number 4 is not on a wedge or a dash. So it would look like this. Group number 4 would be on one of the straight lines. So with that said, let's get into it. The best way to learn how to determine whether a stereocenter is R or S is by doing examples. So let's go over the 3 situations. So what do you got to do? Let's say they give you this structure and they say, determine if the stereocenter is R or S. What is the configuration? So step number 1, like always, we got to find that stereocenter. There, boom, we got a stereocenter. We got a carbon with 4 different groups attached to it. So now, let's rank these groups. Priority group number 1 to priority group number 4 based on their atomic weights. Right away I can identify. We got an oxygen, we got a hydrogen, we got a carbon, and we got a carbon. What atom has the highest atomic weight? Here it is the oxygen. So the OH group will win. Group number 1. We can also see that we got a hydrogen. Hydrogen's always going to be group number 4. So right away I'm going to say, boom, you're group number 4. So all that's left to do is compare our last 2 groups and see who's going to be priority group number 2 and who's going to be priority group number 3. So let's go atom by atom. We got a carbon. Oh no, we got a carbon. Well, we tie. So what do we do when we have a tie? You got to look at what groups are attached to that carbon. So I'm going to call this carbon number 1, and I'm going to call this carbon number 2. Once again, this is arbitrary. This is just so I can tell you guys what carbon I am referring to. Carbon number 1 is attached to a bromine. Put the carbon first, before the hydrogen, because the carbon has a higher atomic weight. So bromine, carbon, hydrogen, attached to carbon number 1. Versus carbon number 2. Carbon number 2 is attached to 2 hydrogens and a carbon. So carbon would go first, then hydrogen, then hydrogen. So then we got to rank the rows, starting at row number 1. Who wins, bromine or a carbon? Easy, bromine going back. Now I just want to be super duper clear here, okay? So what we were doing is we were comparing this carbon, I'll label it in red, to this carbon. I will label it in a dark blue. We could not compare them directly because they are the same. So what we had to do is look at the atoms that they were connected to. So connected to the red carbon, I was looking at a bromine, a hydrogen, and a carbon, okay? I was looking at those 3 groups. So bromine, carbon, and hydrogen, where I rank them going downwards from highest atomic weight to lowest atomic weight. For the blue carbon, I was attached to 2 hydrogens and 1 carbon. So I'm talking about this carbon, carbon, hydrogen, hydrogen. Once again, ranking those groups from highest atomic weight group attached to this carbon to lowest atomic weight group. And then we went row by row, where in the first row we could identify a winner, which was the bromine. Okay, I just wanted to make that very, very clear which atoms I was referring to. It's the atoms directly connected to those 2 carbons that had a tie. So the left-hand side will be the second priority group, and the right-hand side will be the third priority group. So this group would be priority group number 2. And then this group will be priority group number 3. So now, to determine R versus S, what we got to do in case number 1, when group number 4 is in the back, is we got to connect group number 1 to group number 2, group number 2 to group number 3, and 3 back to 1, and see what kind of circle we get. Here, if you go 1 to 2, and you want to think a trajectory, 2 to 3, it keeps spinning, 3 back to 1. What kind of circle did we make? Boom, boom, boom. This is an anti-clockwise circle. Anti-clockwise is going to correspond to S. So, anti-clock. Therefore, S via case number 1. Clean up this circle. You'll usually see this. And we will say S. Case number 1, easiest case. Okay, let's move to case number 2. Pretty similar. Okay, what do we got to do? Step number 1 is always rank your groups 1 to 4 based on their atomic weights. So, starting at your stereocenter. Atom by atom, let's rank them. Okay, the first atom connected to the stereocenter, we got a bromine, a hydrogen, a carbon, and a carbon. Does any of these guys automatically win? Yes, the bromine would win. Bromine is heavier than a hydrogen and a carbon. So, boom, group number 1. Aha, then we see hydrogen is on a wedge, and hydrogen is always group number 4. So what case we got? Case number 2, when group number 4 is on a wedge. Oh no, what am I going to do? It's fine, okay? We got to still rank groups number 3 and 4, and then let's figure out what to do after. So, going atom by atom. On the left-hand side, we hit a carbon. On the right-hand side, we hit a carbon. Oh no, they tie. What do? We got to rank the groups that it is connected to. So left-hand side is connected to a carbon, and a carbon. Carbon, carbon, carbon. On the right-hand side, it is connected to a hydrogen, and a carbon. So carbon's first, highest atomic weight, hydrogen, hydrogen. Compare each row. Row 1, 2, 3. Row number 1, we got a carbon versus a carbon. Nobody wins. Still a tie. Group number 2, though, we got a carbon versus a hydrogen. Who wins? Carbon. Higher atomic weight. Bada bing. Okay, so the left-hand side wins. It shall be named group number 2. And then we got group number 3. So what I want you to do for case number 2 is to draw your circle as if group number 4 is not even there, okay? Step number 1, that's what we're going to do. We're going to draw our little circle and pretend group number 4 doesn't exist to us. We don't care about it, okay? 1 to 2, 2 to 3, 3 back up to 1. Okay, what do we get? We get an anti-clockwise circle if we continue this. Anti-clockwise. So anti-C is equal to S, but in case number 2, when group number 4 is on a wedge, the trick is, all you got to do, and this is a trick, okay? There's harder ways to go about this, but this is the best way. It's the easiest. It's a trick, okay? We say, oh, it's S, but I got to remember it's case number 2, so I actually got to switch it to R. So it's not actually S, it's actually R, okay? And you just got to trust me on this, okay? So whenever group number 4 is on a wedge, you got to do it as per usual, okay? Get your initial type of circle. Here it was S. But then you got to say, actually, magic trick, it's not the S, it's actually the R, and that is my final answer. So if we got that it was an R, then we would say, no, it's actually an S. So you just flip it to whatever you did not get. So here, I'm going to say it one more time. Since we said the circle was S, our actual answer is just going to be the opposite. The actual answer is going to be R. So the answer here is R, okay? R. Via case number 2. Now we got, unfortunately, the hardest case, okay? So case number 3 is when priority group number 4 is neither on a wedge or a dash. But let's not panic just yet, okay? Let's just go through, as per usual, and rank our groups, priority group number 1 to priority group number 4. Let's not freak out, okay? I always freak out right away, but don't, trust me. Learn from my mistakes. Don't freak out right away. Chlorine. Aha. you win. We know this. We went over this example right at the very beginning, if you remember correctly. Then the second largest atomic weight is the fluorine, group number 2. So all that's left to do is compare the left-hand side and the right-hand side groups. Carbon versus a carbon. Oh no, we got a tie. Okay, what do you do? Well, you got to rank the groups that they are connected to. So this carbon is connected to 2 hydrogens and a carbon. Rank them by their atomic weight. Carbon, then hydrogen, then hydrogen. We got a hydrogen, a carbon, and a carbon. So carbon, carbon, hydrogen. Then compare each row. Row number 1, we got a tie again. Can't compare a carbon to a carbon. They are the same. But row number 2, though, we got a carbon versus a hydrogen. Carbon wins. Therefore, this is going to be group number 3. And then, oh no, we got group number 4 is not on a wedge or a dash. What in the world do I do? Okay, we gotta do a rotation. I'm going to walk you guys through this very slowly, okay? So let's pretend this structure is sitting on a piece of paper, okay? If it was sitting on a piece of paper, then these 2 groups would lie flat on the page, whereas the wedge would come out of the page, and the dash would go into the page, okay? Into, and this is out of. So what do we want to do? Well, we want to put group number 4 via the dash. We want it to go into the page, right? Because case number 1, when group number 4 is into the page, it's the easiest, right? So let's rotate this structure into the page. So we want to force group number 4 into the page. When we do that, group number 3 is going to come out of the page. Out of the page. And then group number 1 is going to lie flat on the page. And then group number 2 is also going to come up and lay flat on the page. So what we get is group number 4 goes into the page. 4. Group number 3 ends up coming out of the page. Group number 1 is going to go on a straight line. And group number 2 is going to go on a straight line. So now that we've rotated the groups, all that's left to do is figure out what type of circle we have. So connect the groups 1 to 3. 1 to 2, 2 to 3, 3 to 1. What kind of circle is this? Boom. Oh, it's anti-clockwise again. Again? Yes, it's again. So what we get is S. Anti-clockwise S configuration. Now, what we can do is do one final example. So let's say the question says, find the stereocenter and determine if it is R or S. So here is one of those tricks I was talking about at the beginning of the video. You might say, oh yeah, we got a carbon with a dash and a wedge. This is a stereocenter. But then if you look closer, you say, well, actually it's not, because there's 2 chlorines attached to it. And if you have 2 groups that are the same attached to this carbon, it automatically does not qualify as a stereocenter. Because when we have a stereocenter, we need a carbon that has 4 different groups, okay? So the only stereocenter here would actually be this pink carbon. So now, what do? We got to go and rank each group based on their atomic weights. 1, 2, 4. So group number 4 is an easy identification. We got that hydrogen. And what case is this? Say it with me. This is case number 2. Case number 2 is when we got group number 4 on a wedge. We got group number 1, our OH, because oxygen is going to beat a carbon and a hydrogen. Group number 1. Now when we compare this carbon with this carbon, we say, okay, what are they connected to? Because right now we currently got a tie. This carbon is connected to a carbon, and another carbon. Technically, this double bond is going to count as 2 carbons. So carbon, carbon, carbon. Whereas this carbon, I'll label it in a different color of blue, is connected to a carbon, a chlorine, and a chlorine. So chlorine, chlorine, carbon. It wins in the first row. We got a chlorine versus a carbon. Chlorine always wins because it has because the chlorine has a greater atomic weight than the carbon. So this is going to be group number 2. And then this is going to be group number 3. So all that's left to do from here is draw your circle. 1 to 2, 2 to 3, 3 back to 1. Big circle. Where is this going? Oh, this is going in the clockwise direction. Clockwise R, but group number 4 is on a wedge. So what do? We have to flip it. We say this is actually going to be S. Wow, we got a lot of S's today. I didn't even do this on purpose. But this is how you would do this question. So we had an R, but then we had to flip it to an S. S is our answer. All right, guys. That is it. That is all. Thank you for watching this video. I hope this has been informational and I hope this helped. Please make sure to leave a like, comment, save, or subscribe to my channel. You know the deal if you like my content. And please leave a comment under this video if you have any questions and let me know what type of content you want me to cover next. If you don't leave any suggestions, I will be covering enantiomers versus diastereomers next week or within the next week. I have a very busy schedule. I'm also a master's student right now, but I am trying to get out at least one video a week. I'm really pushing it this week. As you can tell, it's almost midnight, 7 days previously from my last video, but we are still getting that video out. All right, have a great night. Love y'all. Bye.